Okay, so our learning goal today, and I think I should have added to that, I think in your homework you have to graph. I can identify, write, and graph direct variation. So we're still working with linear functions, but today what we're talking about is when we have a special situation, a linear equation that can be called direct variation. Not all linear equations can be, but some of them can. So it starts out, it says, when a linear equation written in standard form. Well, you know what, we gotta go back and remember, what do they mean by standard form? We learned that before break. What is standard form of a linear equation? Anybody remember it? It's got x's in it, it's got y's in it, it's got other letters in it. Anybody remember standard form of a linear equation, Lindsay? Yeah, let's put that above that. Ax, capital A, little x, plus by. The x's and the y's are together on the same side. That is set equal to the capital C constant. It's just a number. Okay. So when a linear equation is written in standard form, which is only one of the many forms we can actually write a linear equation in, when it is written in standard form, and C is equal to 0, this is an important thing right here. When C is equal to 0, then it's that special linear relationship called direct variation. So if you can rearrange the equation, we did that before break, write the equation in standard form, have the x's and y's together on the same side, the constant on the other side. When that constant is 0, you have a direct variation. But here's the deal, rather than writing it in as ax plus by equals 0, rather than having that c be 0 and writing it as something x plus something y equals 0, remember in direct variation we have to have both x's and y's, by the way, so a and b cannot equal 0. The only thing that equals 0 is c. This is the form for direct variation, y equals kx, all small letters, y equals kx. So instead of writing it as ax plus by equals 0, you will see it written as y equals kx. K has a title. It is called a constant of variation. So that k plays the role known as a constant of variation. Okay, so let's explore a situation that represents direct variation. If there are 5 people in a room, each wearing a pair of shoes, what would the total number of shoes be? Okay, 5 people in a room, everybody's got a pair of shoes on. What would the total number of shoes be? 10. And what did you do to get that? You just multiply. You take 5, the number of people, times each of them should be wearing 2 shoes, a pair of shoes, and you get, altogether there would be 10 shoes in the room. What if there are 10 people? Then there'd be 20, because you'd have 10 people each wearing 2 shoes, and now we have 20 shoes in the room. Well, what if there's 15 people? There's going to be 30 shoes in the room. Yeah, 15 times 2, we're going to end up with 30 shoes total in the room. Well, this is a representation of a direct variation. The total number of shoes, how many shoes there would be in the room, varies directly. So this is like, you know what, would you circle this? The total number of shoes varies directly. Let's underline that. In other words, it is determined by, with the number of people. In the room. So you can get how many shoes are in the room by knowing how many people are in the room. The number of shoes varies directly with how many people are in the room. Each time, this is what we did. We multiplied the number of people by 2 to get the number of shoes. the number of shoes vary directly with how many people are in the room. So the number of people got multiplied by 2. And in this case, what do you think the 2 is representing in the direct variation relationship? I think that 2 is representing in there, considering what we just talked about. Let's go up here where it said, K is called a constant of variation. So in other words, the constant, the thing that never changes, is the 2. Every person wears 2 shoes. Well, typically they do. Every person should have on 2 shoes. So the 2 is the constant of variation. The x is the what? What did we multiply by 2? The number of people. So the number of people is x. And what would the y be then? The number of shoes. Yeah, the total number of shoes. So in this case, how could we represent this as an equation? We just said it. To get the total number of shoes, y, you would multiply the number of people, x, by 2. So y equals 2x. What's our constant of variation? We just said that is 2. That does not change. Your constant of variation has to stay the same. Okay? Well, now I want to pose this question. What if there were 2 extra pairs of shoes sitting in the closet? So let's say it's this room right now, and just because I'm never sure which shoes I want to wear, or sometimes I forget to bring shoes. Like today, I have my snow boots on. I forgot to bring a pair of shoes, so I throw my snow boots all day. If I had a couple of extra pairs of shoes sitting back there in the closet, then I'd have some shoes to go grab when I forget. So what if there were 2 extra pairs of shoes sitting in the closet in this room? Would this still be a direct variation? In other words, how many of us are in here today? Let's see, there's 5 of you there, and 6 more is 11, and 4 more is 15, and we'll count me on, so now we're up to 16. There's 16 of us in here. So we're going to call it footwear, because if you say shoes, you'll be like, well, Mrs. Brand, you're wearing boots. So, and some of you might even say your shoes are called boots. So we'll just call it footwear. How many pieces of footwear are there in this classroom? 32 right now. 16 times 2, there are 32 pieces of footwear in this classroom. Well, what if there are those, let's say, each of my 2 classes back there, I got a pair back there and I got a pair back there. How many shoes would there be in here now? 36, because there would be 4 more. Okay? So Officer Hagen, our new resource officer, walks into the room, and now we have 17 people in the classroom, and he's wearing a pair of shoes. So now we would take 17 times 2, and we would have 34, plus the 4 in the closet would make it up to 38. So what do we always have to do because there's shoes sitting in the closet? We always have to add that 4, don't we? So is the number of shoes, the total number of shoes in this classroom, directly being affected by how many people are in here? We can't just take the number of people and multiply by 2. We always have to add that 4. So we would say no to this question. We cannot just multiply the number of people by 2. We have to add 4. We have to add 4. I gotta put the word add in there. We have to add 4 each time. Oopsie, I didn't finish my sentence there. I get back in the habit, get back in the swing of things, okay? So no, we cannot just multiply the number of people by 2 to get the total number of shoes. What did I do this time? We have to add 4. Okay, we cannot just multiply the number of people by 2. Isn't that what we do? We take the number of people, multiply it by 2, and that tells us how many shoes are in the room. If that's all we have to do, then it is a direct variation. But when there's 2 extra pairs sitting in here, we have to add those. We have to add that 4. So now it isn't just affected by how many people are in here. We have to say, oh, wait a minute. We have to add that 4 also because of those extra ones in the classroom. So now we've taken care of, there's no direct variation. What would our equation look like this time? What would this equation look like? Y equals
2x
plus 4. Okay? So let's think about putting that in standard form. What would happen if we put that into standard form? To get it in standard form, what has to be together on the same side? The x's and the y's, right? Yeah, so we would move the x's over with the y's, and then we're supposed to have a what on this side for c? What's c supposed to be in a direct variation? What's c supposed to be in a direct variation? 0. Is it going to be 0? What's it going to be? 4. The c value is going to be 4, not 0. So that's why this is not a direct variation. Any questions so far? Okay, let's go to the back side and let's practice some of the stuff that you're going to have to be able to do in your homework. Identifying direct variation from ordered pairs. When you do it, you have 2 different methods. You have a choice of ways you could do it. One of them is to write an equation to model the ordered pairs. And we learned how to do this already. What do you have to do to x to get y? Remember that? What do you have to do to the x values in the table to get the y values that go with them? And then we can write an equation from that. So what do we have to do to the x value in this table? Anybody think they got it figured out yet? What would we do to the x value to get the y? Multiply? By 3. Does it work every time? 2 times 3 is 6, 4 times 3, 5 times 3, 8 times 3. It works every time. So you multiply x by 3 to get y. So what would our equation look like? What would our equation look like for that one then? Multiply x by 3 to get y. What would that look like? We did this, believe it or not, back in 2016. Austin? Okay, so can we just write it as 3x? Does that mean x times 3? And that equals y? Okay, so, or could this be rewritten like this, y equals 3x? Can the y be on this side, on the left side, and put the x's on the other side? Does it matter? No. Is this direct variation? Yeah, it is, isn't it? It's direct variation because it's of the form y equals kx. The only thing you do is multiply the x by 3. What's the c value in this one? Is anything being added or subtracted from the x's? No. If there's nothing being added or subtracted to the x's, it is direct variation. So we'd say this is direct variation. Okay, we're just going to put like a little division line here because we're going to right away do method 2 also on this one before we jump to letter B. They each are their own, okay? So the other method is this. If in a direct variation, you should be able to put the y over the x every time from every ordered pair in that table. You should be able to put the y over the x, and every single time you should get the same number when you simplify it. So here's what we will do. We will put 6 over 2. 6 is our y value. 2 is our x value. 6 over 2, what does that equal? 3. Next one in the table, 12 over 4. What does 12 over 4 equal? 3. 15 is our next y value over the x value that goes with it, 5. 15 over 5, what does that equal? 3. You're starting to think, well, we already kind of did this. Yeah, we did it by trying to figure out what you do to x to get y. What we're doing instead is saying, what relationship does y over x have every single time? And what's our last setup? scrolled down too far. 24 over 8. And what is 24 over 8? Simplified to 3. So we would say this is direct variation because we got the same value every single time. So we would say is direct variation. And when we were actually setting up those y over x's, we were determining if there was a k value. We would say k equals greater. Just like it does up here in our equation, k equals 3 up here also. Y equals kx. So our constant of variation, our k value, is 3. Okay, now let's try the next one. Letter B. Look at that table, ordered pairs. Can you tell me what you got to do to the x values to get the y values in that table? Chase?
Subtract 3.
Subtract 3. Every time it works? Do you all agree? If we subtract 3 from x, every time we will get the y value. 8 take away 5 is, or 8 take away 3, I mean, is 5, and 7 take away 3 happens to be 4, and 4 take away 3, oh yeah, that's 1, and 3 take away 3, oh yeah, that's 0. So we would say subtract 3 from x to get y. So what would that equation look like? Y equals, how do we get our y? Y equals, not 3 minus x, but x minus 3. Okay, remember what direct variation looks like? Y equals kx. In other words, nothing is being added to the x's or subtracted from the x's. Is this direct variation? This one is not direct variation. In other words, if we moved those x's over with that y so that it was in standard form, what would our c value be? -3. What does the c value have to be in direct variation? It has to be 0. It has to be 0. Okay, so that's using the equation method. But you get to choose. Which method are you going to use to prove it? Method 2 says, well, here's what you do in method 2. You set up the y over x relationship. So 5 over 8. Calculator might be handy right now. Because we're going to simplify this. Or we're going to rename it, as a decimal so that we can see if we get the same answer every time. Okay, what is 5 divided by 8? Uh-oh, the calculator didn't make it back to school. Benton? 0.625. 0.625, okay? Our next one, 4 over 7. Probably not a nice decimal, is it? What does this one count? Actually, it's almost like, you use a calculator. I guess they did a good job in 2016 of making you work with that one. Let's round this to the nearest hundredth if you have to. If it doesn't, does it ever stop, by the way? Does this one ever stop? What does it do? 0.5. Calculator doing 4 divided by 7. 0.5, 7, 1, 4, 2. Yeah, it takes a while for it to have a repeating pattern, doesn't it? So let's round this and say it is approximately equal to 0.57, could we say? 0.56. Does the next number allow us to round it to a 7? No? It doesn't? Oh, okay, well then we better keep it 0.6, huh? Okay, so can I trust you guys? Tell me what the first 3 digits are after the decimal point when you do 4 divided by 7. 0.5, 7, 1. Oh, so it can be 5, 7. I thought it was 0.56. I thought I heard you guys say that earlier. Okay. Well, right now, has it already broken down? Remember, these always have to turn out the same. So it's already broken down. We don't even have to finish. We don't even have to finish. Every single one of these y over x relationships has to be the same value like it was over here in our A1. We ended up with 3 every time. Over here, it's already broken down. This is not the same as that. So we would say is not direct variation. Because no constant of variation. In other words, we needed it to keep turning out the same. That's what constant means. But it did not keep turning out the same. So it's not direct variation because there's no constant of variation. We got a 0.625, we got a 0.57, blah, 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 blah. And I bet if we divided the other ones out, they wouldn't be any better. So when you are determining from a set of ordered pairs whether it is direct variation or not, you have one of 2 methods to choose. You can either say, here's what's happening to x to get y, and write an equation, and then from that equation determine, does this represent direct variation? Or you can choose to do the y over x and check to see if there's a constant of variation every time. So you have 2 choices here. There's 2 methods, 2 ways to go about it. So we just practice both of them for both of them so that we can see what would happen. Anybody have any questions? Okay. Writing and solving direct variation equations. That's another thing you're going to do in your homework. And I'm not saying that we're covering everything you're going to do. This is another thing that is kind of confusing. Writing and solving direct variation equations. If y varies directly with x, in other words, they're telling you, you can count on this. If it is, they're saying the y is going to be varying directly with the x. In other words, something is going to happen to that x, and the only thing that's going to happen is a multiplication. If x is being multiplied by something, and nothing's being added or subtracted, so they're telling you you have a direct variation relationship, and you are given at least one ordered pair. They give you just one ordered pair. That's all they give you. But just from that one ordered pair, you should be able to find the k. You can find the k, and then you can use an equation relationship to solve for the missing information. Okay, so let's just practice it. And there's some more examples in your book on this. So basically, we have a direct variation relationship, and I want you to circle this. This is what you're given. They're telling you right here, you have ordered pair 0.5, 4.5, 1/2, 4.5. Your x value is 1/2, your y value is 4.5, also known as 0 and 5/10, 4 and 5/10. You have that ordered pair. It comes from a direct variation relationship. We know that in a direct variation relationship, there is a k value. And how do we get that k value? Well, we put a y over an x. Y over x gives us the constant of variation. In that one, it turned out to be 3 every single time. That was the constant of variation. K equaled 3. So all we need is 1y over x to put, so y over x. That's all we had to do to get k. Then once we have k, we're going to be able to write an equation, and then we can use that equation to help us find some missing information. So what are we going to have here? We're going to have 4.5 over 0.5. Or in other words, it's asking us how many halves are there in 4.5? How many 50 cents are there in $4.50? How many half dollars are there in $4.50 worth of half dollars? 9. Our k value is 9. So now that we know our k value, now we can write an equation. So we'll just go up here, we'll write our equation y equals 9x. K is 9. Y equals kx, remember, is the model. So maybe you want to write that above it. Y equals kx. That's the model for direct variation. Y equals kx. We know that k is 9 now. So now that we know that k is 9, we should be able to substitute in, and for this relationship, find y when x equals 10. So what are we going to do? Put 10 in for x. They tell us x equals 10, so we'll say, here's my equation. I'm looking for y this time, so I'll leave y, y. I'll put 10 in for x. I'll do my multiplying, and what is our y value? 90. So we just found what they wanted us to find. The y value. So in other words, we have another ordered pair for this direct variation relationship. Ordered pair now 10, 90. Anybody have any questions on either of these things we practiced on the back side? Being able to determine the set of ordered pairs is direct variation, or knowing that we have a direct variation relationship, can we find some missing information? Okay, and let's just get you started on your homework.